Okay, welcome to part two of our study of parabolas as we look at the geometric interpretation of parabolas as opposed to the arithmetic interpretation of parabolas. So you can see from this page taken out of the book that it's quite easy to make parabolas pretty difficult. Your book breaks it down to 4 separate cases. It has all these rules that are so important they put it into a box. But we don't need to look at it that way. Let's try to understand the concept and then let logic be our guide in figuring out how these parabolas unfold. So, first things first, let's take a look at a basic parabola. So this, I don't know what this is called, this salmon colored shape here, this U shape, this is the parabola. And remember, geometrically, a parabola is the set of all points that are equidistant from this red focus, and the focus is always inside the parabola, and a given line, which is called the directrix. So every point on this parabola is the same distance from that focus as it is the directrix. Now up here we have our general equation for a parabola. And you've seen this general equation last year in Algebra 2. But in Algebra 2, I think you called this coefficient A. But that's actually a very meaningful number geometrically in the parabola. It is actually 1 over L, and L stands for the length of the latus rectum. Now remember, the latus rectum is the segment that goes from one side of the parabola to the other side of the parabola. It's parallel to the directrix, perpendicular to the axis of symmetry, and it has to pass through the focus. And it turns out that its length is 1 over L. Well, its length is L. This number here is 1 over L. So we'll get into where these numbers come from later on, and we'll discuss it. But for right now, what you need to know is the focus bisects the latus rectum. So this length is a half L, so is this. And it also turns out that the focus is a fourth of L away from the vertex. And the directrix is also a fourth of L away from the directrix. So when we're trying to figure out all these different characteristics, these geometric characteristics of a parabola, if we can get this general form of a parabola written, it all comes from the latus rectum. The latus rectum is the key to figuring out all these coordinates. Let's see how that works. So here's our first set of problems, and you may need to pause the video to write some of this stuff down, and you may also need to pause the video to try some of the problems on your own, but come back to it and make sure you have these correct. So I need to identify the coordinates here of the focus, the vertex, the endpoints of the latus rectum, and then I would like the equation of the directrix. Remember, the directrix is the line, and the equation of the axis of symmetry. So here's my first problem, and those are all the things I'd like to find in this first problem. So let's get started. Well, first of all, notice it's written exactly as I want it to be written. And before I get started with anything, I think what we want to do is get a very quick sketch of what's going on. So our base parabola here is a y equals x squared parabola. And we know that that is a vertical parabola that's opening up. So real quickly, I'm going to sketch this vertical parabola opening up. I'm going to identify the vertex first. That's an easy one. We know the vertex is 5, 7. So right there, that vertex is 5, 7. And then I'm going to sketch the directrix down here and the focus. Now remember, the focus is always inside the parabola. So the focus in this case is going to go right through there. And I know that the length of the latus rectum is 8. Remember, this number is 1 over the latus rectum length. So it's the reciprocal of that number, so it's 8. So I went ahead and I labeled that this part would be 4 and that part would be 4. Now remember, the distance from the focus to the directrix is a fourth of this length, or it's half of this half. Half of a half is a fourth. So if this number is 4, this number would be 2, and that number would be 2. Now, Based solely on the vertex, which again is one of the easiest coordinates to get, and based solely on taking the latus rectum, splitting it in half, and splitting half of that again in half, we can use logic. So what's Mr. Brath say? He says, let's let logic be your guide. By the way, this picture was taken in the summer. It's why I'm a little bit more tan than usual. So let's see. If I'm at the point 5, 7, and I go down 2, because that's what's happening. To get to the directrix, we go down 2. My new point would be 5, 5. And if I'm at the point 5, 7, and I go up 2, my new point would be 5, 9. And if I'm here at the focus at 5, 9, and I go to the right 4, I would be at 9, 9. And if I went to the left 4, I would be at 1, 9. Do you see how moving up affected the y's and moving left and right affected the x's? So now I can fill in all of these values. The focus is 5, 9. The endpoints of the latus rectum would be 1, 9 and 9, 9. The directrix, now it's the equation of the directrix. It's a line, and it's a horizontal line. So that's a y equals 5. And then finally, the axis of symmetry, that's a vertical line. And so that's an x equals, and the axis of symmetry clearly passes through these three x values, 5, 5, and 5. So it's x equals 5. So let's try another problem. I'm going to go ahead and put this one up here, and why don't you maybe pause this and see if you could figure this one out for yourself. Go ahead and see how you do. Hey, welcome back. Hopefully you did this the right way. Let's see. So those are my answers. And if you're celebrating, good for you. Move on to number 3. But if you didn't get it right, let's take a little look at this and see what happened. So I'm going to come over here and I'm going to look at my graph. Now, did you notice that the graph is going down? Why? Because the general form is y equals a negative x squared. So my parabola has to go down, which means the focus is below the vertex and the directrix is above. Remember, the parabola will never, ever, ever touch the directrix. It wraps itself around the focus. So in this case, my latus rectum has a length of 10, so I split it up to 5 and 5, and that means that this distance here is 2.5, as is that. And then you can go ahead from there and you can find all the other pieces. Remember, we're going up for the directrix, and we're going down for the focus, and then we go to the left and to the right there for the latus rectum. Well, let's try another one here and see how you do. Ooh, look at that screen. Turquoise. Ooh. So here's another one. Why don't you see if you can pause the video and figure this one out. So go ahead and hit pause. Hey, welcome back. Hopefully you realize that something strange was afoot. This is not a y equals x squared. This is an x equals y squared. So that is a sideways parabola. So when you sketch this sideways parabola, hopefully you realize that it opens to the right. It opens towards the positive x's because this is a positive out in front. So let's fill in these parts and see how you did. The vertex, now remember the vertex, the coordinates are x first, y second, and the x value is -3 and the y is -4. So that vertex is -3, -4. So when we come over here and we label these parts somewhere here, somewhere, where maybe there, -3, -4. How long is this latus rectum? Well, the latus rectum has a length of 6. So I'm going to split that 6 up into 3 and 3. And I'm going to split this into a half. So half of 3 is 1.5 and 1.5. And from there, we can just use our logic and our reasoning. From this point, -3, -4, we're going to go to the right 1.5, which means we change the x values. From this point, we're going to go to the left 1.5, which gives us that x value, and that gives us our directrix. From this focus, we'll go up 3, which changes the y, and down 3, which changes the x. And of course, our axis of symmetry this time is a horizontal line. So it's a y equals, and you can see it's -4. So if you got that right, congratulations. We'll celebrate with a little screen color change. Okay, let's do one last one here and see how it works. All right, well, why don't you go ahead and pause the video and see if you can solve this last one by yourself. Okay, welcome back. Welcome back to the video. Here's my graph. Again, this is an x equals y squared, so it's a sideways parabola. And where's the vertex? Well, let's see. Sometimes kids, I think, find this easier to rewrite as x equals 1/8 times y minus 0 squared minus 4. So the vertex is at -4, 0. How long is the latus rectum in this case? Well, the latus rectum has a length of 8. Remember, it's the reciprocal of the number in front. So that means we're going to split it up into 4 and 4. And then we take half of this half, and that gives us 2. So, coordinates of the focus, -2, 0, because we went from the vertex to the right 2. Endpoints of the latus rectum, from this focus we go up 4 and we go down 4. The directrix, well, this directrix right here, if we're at -4, 0 and we go left 2, it's -6, 0. And finally, the equation of the axis of symmetry is y equals 0. So, let's do just 2 more problems and see how this goes. Problem number 5, you'll notice, is not written in a way that is conducive for graphing. So we're going to have to play around with this, and I think that means complete the square. So you may want to pause this and try to complete the square on your own. Let's see how it goes. Well, the first thing I'm going to do is I'm going to group this so the x's are together and the 17 is off by itself. I don't want anything with a y, but I don't want the 17 connected with these two. Second thing, to complete the square, I don't want that 4 there, so I factored that 4 out. Now, I complete the square. So when you do that, we want to add a 4 here. So I add a 4 there, but I hope you realize that's really not a 4. That number is a 16. So to balance out that 16 I added, and again, remember, I want to keep the y alone. So to balance out this 16, I need a -16. And when I clean this up, that's the equation I have. So it's y equals 4 times the quantity of x minus 2 squared plus 1. So you can come over here. Why don't you pause the video, see if you can set up the graph, see if you can find your points. You're going to be working with some fractions. See how it goes. All right, so there is my parabola. I did a quick little sketch. The vertex is at 2, 1, and I filled in all these values, remembering that this number here is really the reciprocal of the latus rectum. Okay, well, tomorrow we're going to work on this problem, but for today you have enough to do part of your homework. So good luck on that, and I'll see you later.